How do we relate the gradient with the function and the stationary point? Let us look into it. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll have an excellent question based on integration and application of antiderivatives. The question here is, function has gradient of 2 square root x plus a over square root x and passes through the points 0, 2 and 1, 4. Find the value of a. Show that the function has no stationary points. I'd like you to pause the video, answer the question, and then look into my suggestions. Well, we are given the gradient of the function. First, we need to find the function itself. How are you going to find that? Let's write down the gradient. So the gradient of the function is given to us as equal to 2 square root x plus a over square root x. To find the function, we'll take integral, right? So integral of the derivative gradient will be the function itself, correct? So 2 square root x plus a over square root x dx. So on the left hand side, we get the function f of x, and here when you integrate, we get 2 times x to the power of half plus 1, 3 by 2 over 3 by 2 plus a times x to the power of minus half plus 1, which is half, over half, plus the constant c. To find the value of the constant c, we can substitute one of the points given to us, which is 0, 2. Since we know that f of 0 is equal to 2, substituting 0 here, we get 0 plus c gives us the value of c as equal to 2, correct? And so we have the function now. The function is f of x equals to 2 times x to the power of 3 by 2 over 3 by 2. So that gives you 4 over 3 x to the power of 3 by 2 plus a divided by half is times 2, right? So plus 2a square root of x, and then the value of c, which is plus 2, correct? So that becomes the value of the function. Now to find the value of a, we can substitute the second point, which is 1, 4. So if I substitute 1 for x, then 4 is the f of x value. So we are substituting 1, 4 here now. So we get 4 equals to 1 for x will give me 4 over 3 plus 2a plus 2, correct? So now we can write down 4 minus 2 minus 4 over 3 as twice a, which is 2 minus 4 over 3, right? So which is 2 minus 4 over 3 equals to 2a, which is 6 minus 4 over 3 equals to 2a. 6 minus 4 is 2 over 3, right? So that implies that a is equal to 2 over 3 divided by 2, which is 1 over 3, correct? So we have the value of a as 1 over 3. Now, we have the value of a, which is equal to 1 over 3. Let us find the solution of the second part, which is show that the function has no stationary points. So let's go to a fresh page. We are given now that the derivative of the function is equal to 2 square root x plus a over square root x, and we found that a is equal to 1 over 3, right? So substituting 1 over 3 here, we get 2 square root x plus 1 over 3 square root x. So that becomes the derivative of the function. Now, we need to show the function has no stationary points. Now, for a stationary point, the derivative should be 0. So let's equate 0 for the derivative and solve for x, which is 2 square root x plus 1 over 3 square root x. Multiplying by square root x, we get 0 equals to 2x plus 1 over 3. And from here, we get the value of x. So 2x is equal to minus 1 over 3. Or x is equal to minus 1 over 6. So we have stationary point at x equals to minus 1 over 6. However, if you look at the function itself, then the restriction is that x should be greater than 0, correct? X cannot be negative value, right? As you can see, the function which we got was 2a square root x, right? So 2a square root x means that the x value has to be greater than or equal to 0, right? And in the derivative, denominator is square root x, so x cannot be equal to 0. So we see that x has to be greater than 0. And since we got x value of minus 1 over 6, we say this does not exist, right? And hence, no stationary point. So I hope that is absolutely clear. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.